Ethernet is a layer 2 protocol that operates, and it's widely used, and it's most likely it's operating in your home and if you work for a company. So it is very prevalent out there, and so we're going to spend quite a bit of time taking a look at Ethernet and how Ethernet works. So we'll start out by talking about the sublayers of Ethernet, and then we'll get into what a MAC address looks like. This is going to be a very high level around MAC addresses. Then we'll get into what the trailer and header look like of an Ethernet frame. And then we'll talk about ARP and how ARP works. And then we'll talk about a default gateway. So let's get started. So Ethernet is considered to run off of both the physical and data link layers. We can see it interfaces with layer 3 of the OSI model, which is the network layer, but it runs within the physical and data link layer. The data link layer actually has two different sublayers, an LLC layer sublayer and a MAC sublayer. And so there's two different sublayers. The LLC sublayer is defined by IEEE 802.2, whereas both the MAC sublayer and the physical layer is actually defined by 802.3, and we can see these with these different standards that are out there. They all start with 802.3, and then there's different iterations of this. So here's the I, the U, the AB, the AE, BQ. You can imagine there's everything in between these. There's more after these. There's more before these. But this gives you kind of a range of some of the different standards that are out there. This 10 represents 10 megabits per second versus 100 megabits per second versus 1,000 megabits per second, or gigabits per second. One gigabit per second. There's a 10 gigabit. There's a 40 gigabit. Some of these represent the copper lines, the standard for how copper lines communicate, while others of these are fiber. So we see a whole different range of different speeds within here, and it defines how the signaling happens and defines all of the intricacies of each one of those standards out there. So that's the sublayers over here, and then how these are defined using the IEEE standards. All right, there's a lot to be said around MAC addresses and what MAC addresses look like. This is not the time we're going to fully discuss what a MAC address is. We're just going to take a glimpse into what it is. As you can see, there's these numbers right here and a few letters in there. That's because it's hexadecimal. And so these are actually MAC addresses. You'll see a lot of different varying MAC addresses that are out here. They come on the hardware itself. So if I were to buy a computer, or if I were to buy a laptop, then it has some sort of network interface card, or NIC. Usually it's built into the motherboard nowadays, but it has some sort of NIC that's on the machine, and that each one of those interfaces come with what's called a burned-in address, or an address that's hard-coded onto that machine. There are some ways to override that, so as you send out frames, it will have a different MAC address, but for the most part, whatever frame is coming out of that NIC has a source address of whatever MAC address is burned into or assigned to that network interface. And so MAC addresses are a way to address network interface cards. So as information is sent out of that card, it leaves destined for another MAC address. So you have a source MAC address that it's coming from and a destination MAC address that it's heading to. And so that's how MAC addresses are used. So in this particular one, we're going to use MAC addresses to explain Ethernet and how Ethernet works and how Ethernet uses MAC address for this communication to happen. So as we're beginning to see how this is all coming together, we see that as a frame leaves the NIC card, it is heading from some MAC address, some NIC card with a burned-in MAC address, going to some destination MAC address. And so it's going to travel along this way with a destination MAC address of wherever it's trying to go to, and with a source MAC address of where it's coming from. Now the thing is, we typically in our communication are not typing a bunch of MAC addresses in the machines to make this happen. In fact, what we're probably doing is we're going to, like if we're going to a website, we're using some sort of domain name. Well, that doesn't quite directly translate to a MAC address. And so what we have to do is we have to translate that domain name into an IP address, and then from an IP address possibly into a MAC address. So if we are going to this destination right here to wherever the server is, we're probably typing in something other than the MAC address. And eventually that's going to come up with this machine has an IP address that's tied to it, and you're somehow getting that IP address and need to communicate to that IP address. This machine doesn't know what IP address is associated or what MAC address is associated with that IP address. It needs to find out that information in order to form the frame. So this machine needs to know the destination MAC address of that IP address. And this is all as if it was communicating on a local area network. And so what it does is it sends out a ARP request, an address resolution protocol. So it sends a request out onto the line and says who belongs to this IP address. And this machine hears that. What happens is that that request gets sent out all of the ports. This machine hears that, says, yes, that IP address belongs to me. And so what I'm going to do is I'm going to reply to that to let this machine know that this is the MAC address it needs to communicate to. And so now this device has the IP address. It knows what MAC address is associated with it because it did the ARP request and got a reply back. And now this machine will form that frame with the destination MAC address and put it out on the line. This switch then will forward it on to this server right here, and then this server will get that information. Now, since this device right here has a source MAC address that it sends across, this machine knows, hey, I need to send it back. So when it replies, it uses the destination address, or it uses the source address of this in the new destination address to get the information back. Now that works great, but what if the IP address of the machine is somewhere outside of the network? So it's a whole nother network. We already know MAC addresses are used to communicate on the local LAN, but it doesn't work once you get beyond the router. And so what happens is that a machine will recognize if an IP address it's trying to reach is outside the network. And if it's outside of the network, then what it's going to do is it has something called a default gateway. The default gateway on the machine is usually the router that's sitting on the end of your edge of your network. And the machine is going to say, if I'm trying to communicate to an IP address that's outside of my network, then what I need to do is I need to send this information to the default gateway. And I don't know what the MAC address of the default gateway is. So then the next question is, how does it figure out the MAC address? If you answered that it does an ARP request, you would be correct. So it has an IP address of the default gateway. It sends a message out to that IP, or an ARP request out to that's destined to that IP address. The ARP request gets flooded out of all connections. This router receives that ARP request, recognizes that's an ARP request for the IP address that I have. And so what I'm going to do is I'm going to reply back. Now this machine knows the MAC address of the default gateway, and it can then form a frame, an Ethernet frame, using the source destination or source MAC address of itself and the destination MAC address of the router. send it to that router, and then that router handles it as it goes externally outside of the network. All right, so we've been talking about Ethernet. We talked about the sublayers of Ethernet. We talked about some of the addressing that it uses, specifically the MAC addressing that it uses. Just a brief overview of that. We talked about quite in depth about the Ethernet header and trailer, the frame, the Ethernet packet, and what all that looks like. Even got down to the ones and zeros. We finished up with an address resolution protocol and what that looks like and how it translates when you know an IP address but need to know the MAC address. Then it goes through an address resolution protocol to figure out the MAC address of where it's trying to reach and then be able to send that information that way. And then we finally talked about the default gateway. That if a machine recognizes that it's trying to communicate to an IP address outside of the network, then it needs to reach the default gateway. And so it will do an ARP request for that default gateway so it has a MAC address that it knows now where it needs to send that information. If you like this video, could you hit that like button?